8th grade Open Up Resources Illustrative Mathematics, Unit 6, Lesson 1, Organizing Data. Problem number 1. Here is data on the number of cases of whooping cough from 1939 to 1955. A. Make a new table that orders the data by year. Here I've organized the data in order from 1939 to 1955. B. Which years in this period of time had fewer than 100,000 cases of whooping cough? Here you can see that the years 1948, 49, 51, 52, 53, 54, and 55 had fewer than 100,000 cases of whooping cough. C. Based on this data, would you expect 1956 to have closer to 50,000 cases or closer to 100,000 cases? By looking at the data, I can see the number of cases decreases over time. So I would expect that 1956 would most likely have closer to 50,000 cases than 100,000 cases. Problem number 2. In volleyball statistics, a block is recorded when a player deflects the ball hit from the opposing team. Additionally, scorekeepers often keep track of the average number of blocks a player records in a game. Here is part of a table that records the number of blocks and blocks per game for each player in a women's volleyball tournament. A scatter plot that goes with the table follows. Label the axes of the scatter plot with the necessary information. We have a horizontal axis and a vertical axis. Since the horizontal axis goes up to 30 and the vertical axis only goes up to 2, the horizontal axis could be labeled as blocks, and the vertical axis could be labeled as blocks per game. Initially, I thought this looked pretty unusual because there were 0.5 blocks and 7.5 blocks, 1.5 blocks, but then I reread the information, and it said that they were keeping track of the average number of blocks a player records in a game. So if this is the average number of blocks, that would make sense. Problem number 3 from 8th grade Unit 5, Lesson 18. A cylinder has a radius of 4 centimeters and a height of 5 centimeters. A. What is the volume of the cylinder? The information tells us that the radius of the cylinder is 4 centimeters and the height of the cylinder is 5 centimeters. We can plug that information into the formula. Volume equals pi times r squared times height. We can substitute r with a 4 and substitute the h with a 5. The volume equals pi times 4 squared times 5. We can rewrite this as volume equals pi times 16 times 5. And since 16 times 5 is 80, we can rewrite this as pi times 80 centimeters cubed or 80 times pi centimeters cubed. So the volume is 80 times pi centimeters cubed. B. What is the volume of the cylinder when its radius is tripled? Well, originally the radius was 4 centimeters. If we triple 4, we get 12. So now we can substitute the r with a 12. The volume equals pi times 12 squared times the height. Since the height is 5, we can substitute the h with a 5. 12 squared equals 144, so the volume equals pi times 144 times 5. 144 times 5 is 720, so the volume would be 720 times pi centimeters cubed. C. What is the volume of the cylinder when its radius is halved? That means its radius would be cut in half. Half of 4 centimeters is 2 centimeters, so we can substitute the r with a 2. Volume equals pi times 2 squared times 5. 2 squared, or 2 times 2, is 4, and 4 times 5 is 20. So the volume of this cylinder would be 20 times pi centimeters cubed. 8th grade Open Up Resources Illustrative Mathematics, Unit 6, Lesson 2, Plotting Data. Problem number 1. In hockey, a player gets credited with a point in their statistics when they get an assist or goal. The table shows the number of assists and the number of points for 15 hockey players after a season. Make a scatter plot of this data. Make sure to scale and label the axes. Here you can see the scatter plot. The horizontal axis represents the assists, and the vertical axis represents the points awarded. Both the assists and the points are displayed in 5-unit increments. I'll quickly match each set of data with its matching point. 22 assists, 28 points. 16 assists, 18 points. 46 and 72. 19 and 29. 13 and 26. 9 and 13. 16 and 22, 8 and 18, 12 and 13, 12 and 17, 37 and 50, 7 and 12, 17 and 34, 27 and 58, 18 and 34. Problem number 2. Select all the representations that are appropriate for comparing bite strength to weight for different carnivores. First, let's just take a quick look at examples of each of these types of representations of data. A histogram. B, scatter plot. C, dot plot. D, table. E, box plot. The two types of representation that I choose are scatter plot and table. I especially like the table because it's easy to read. Problem number 3. When is it better to use a table? I find it better to use a table when you want to see precise information. And the second question for problem number 3 is, when is it better to use a scatter plot? I like to use scatter plots when I'm looking to see if there's a pattern or maybe if there's no pattern. So let's look at this scatter plot. You can see that there's kind of a pattern. The dots are hovering along that line. They're very close to that line, and that shows a pattern. Problem number 4 from 8th grade Unit 5, Lesson 17. There are many cylinders with radius 6 meters. Let H represent the height in meters and V represent the volume in cubic meters. A. Write an equation that represents the volume V as a function of the height H. The volume as a function of the height. That means that V, the volume, depends on the height of the cylinder. The volume of the cylinder depends on the height of the cylinder times pi times the radius of the cylinder squared. For this problem, the radius is 6 meters, so we can substitute the r with a 6. And 6 squared is 6 times 6, or 36. So the equation becomes V equals 36 times pi times the height. B. Sketch the graph of the function using 3.14 as an approximation for pi. If the height of the cylinder were 0 meters, then the volume would be 0 meters cubed. And we can show that point on the graph. If the height of the cylinder were 1 meter, then the volume would be 113 400 meters cubed. Because 3.14 times 36 times 1 is 113.04. I'll show that point on the graph as well. If we doubled the height of the cylinder from 1 meter to 2 meters, then the volume would also double, making the volume 226 800 meters cubed. Because 3.14 times 36 times 2 equals 226.08. And I'll also show that point on the graph. Let's make one more example, and this time the height will be 5 meters. Pi, or 3.14, times 36 times 5. Since 36 times 5 is 180, we have 180 times pi meters cubed. 180 times 3.14 is 565 2/10. So the volume of this cylinder would be approximately 565 and 2/10 meters cubed. Here are the points on the graph. With a height of 0, the volume is 0. With the height of 1 meter, the volume is 113 meters cubed. Double that height and your volume doubles. So a height of 2 meters brings a volume of approximately 226 meters cubed. You'll notice that this is making a straight line. The relationship between the height of a cylinder and the volume of the cylinder is proportional. For the last point, the height of 5 meters is 5 times greater than the height of 1 meter, and its volume is also 5 times greater. C. If you double the height of a cylinder, what happens to the volume? Explain this using the equation. In these examples, the cylinder on the left has a height of 5 meters and the cylinder on the right is doubled. It has a height of 10 meters. So essentially, we're just substituting the value for h either with a 5 or with a 10. And in doing so, the volume also doubles. D. If you multiply the height of a cylinder by 1/3, what happens to the volume? Explain this using the graph. Multiplying by 1/3 is the same thing as dividing by 3. So you'd actually be making the height 3 times smaller, which means you'd be making the volume 3 times smaller. Let's use this graph as an example. You can see that there's a point that represents a cylinder that has a height of 12 meters, and there's a point that represents the volume of a cylinder that has a height of 4 meters. And of course, 4 is 3 times smaller than 12, and the volume of that cylinder is 3 times smaller than the taller cylinder. Eighth grade Open Up Resources, Illustrative Mathematics. Unit 6, Lesson 3. What a point in a scatter plot means. Problem number 1. Here is a point in a table and a scatter plot that compares points per game to free throw attempts for a basketball team during a tournament. A. Circle the point that represents the data for player E. The information tells us that player E averaged 3.1 free throw attempts per game and 10.4 points per game. So I would circle this point here. B. What does the point 2.1 and 18.6 represent? 2.1 and 18.6 represents the statistics for player B. C. In that same tournament, player O on the other team scored 14.3 points per game with 4.8 free throw attempts per game. Plot a point on the graph that shows this information. Starting at the origin in the lower left-hand corner, I can move to the right 4.8 units to represent the free throw attempts per game, and then I can move up vertically 14.3 units to represent the points per game. The point for player O would be located right here. Problem number 2 from 8th grade, Unit 6, Lesson 2. Select all the representations that are appropriate for comparing exam score to number of hours of sleeping the night before the exam. Those representations would be a scatter plot and a table, so I would select B and D. Problem number 3 from 8th grade, Unit 5, Lesson 17. A cone has a volume of 36 times pi centimeters cubed and height h. Complete this table for volume of cylinders with the same radius but different heights. When the height is 1h, the volume in centimeters cubed is 36 times pi. When you double 1h, you have 2h. Since you doubled the height, you double the volume. 36 times 2 times pi is 72 times pi. For the next one, it's 5 times h. So we need to multiply 36 times 5 times pi. When the height is 5h, the volume is 180 times pi centimeters cubed. The next one is h over 2. That means the height divided by 2. Since we're dividing the height by 2, we have to divide the volume by 2. 36 divided by 2 is 16. So when the height is h over 2, the volume is 16 times pi centimeters cubed. The last one is h over 5. That means the height divided by 5. Since we're dividing the height by 5, we need to divide the volume by 5. 36 divided by 5 times pi centimeters cubed. We can leave this as an improper fraction, or we can write it as a decimal. 8th grade, Unit 6, Lesson 4, Fitting a Line to Data. Problem number 1. The scatter plot shows the number of hits and home runs for 20 baseball players who had at least 10 hits last season. The table shows the values for 15 of those players. Use the graph and the table to answer the questions. A. Player A had 154 hits in 2015. How many home runs did he have? How many was he predicted to have? He had 154 hits, 26 home runs, and he was predicted to hit 21.6 home runs. B. Player B was the player who most outperformed the prediction. How many hits did player B have last season? The graph showed that player B has a little bit more than 50 hits and a little bit more than 15 home runs. So on the table, player B must have 57 hits, 16 home runs, and the prediction was 7.1 home runs. C. What would you expect to see in the graph for a player who hit many fewer home runs than the model predicted? The point would be much lower on the graph than the line. I'll circle a few of these points on the graph. Problem number 2. Here is a scatter plot that compares points per game to free throw attempts per game for basketball players in a tournament. The model, represented by y equals 4.413x plus 0.377, is graphed with the scatter plot. Here, x represents free throw attempts per game and y represents points per game. A. Circle any data points that appear to be outliers. I notice this one outlier. B. What does it mean for a point to be far above the line in this situation? A point above the line means the player scored more points than predicted. C. Based on the model, how many points per game would you expect a player who attempts 4.5 free throws per game to have? Round your answer to the nearest tenth of a point per game. That would be 4.413 times 4.5 plus 0.377, which equals approximately 20.2. D. One of the players scored 13.7 points per game with 4.1 free throw attempts per game. How does this compare to what the model predicts for this player? 4.413 times 4.1 plus 0.377 equals approximately 18.5, which means the player is scoring less than predicted. 8th grade Illustrative Mathematics, Unit 6, Lesson 5, Describing Trends in Scatter Plots. Right now, click that like button. I appreciate it. Problem number 1. A. Draw a line that you think is a good fit for this data. For this data, the inputs are horizontal values and the outputs are the vertical values. Just draw a line that goes right through the middle of all the data points. B. Use your line of fit to estimate what you would expect the output value to be when the input is 10. Remember, the inputs are the horizontal values, so when the input is 10, the output would be about 30. Problem number 2 from 8th grade Unit 6, Lesson 3. Here's a scatter plot that shows the most popular videos in a 10-year span. A. Use the scatter plot to estimate the number of views for the most popular video in this 10-year span. To find the most popular video, we'd have to find the video that has the most views. The vertical axis represents the views in billions. Let's find the point that's at the highest part of the graph. That's not quite 3 billion views. It's just about 2.8 billion views. B. Estimate when the fourth most popular video was released. The fourth most popular video will be the point that's fourth from the top. The release dates are shown on the horizontal axis along the bottom. So scroll straight down and you'll see that the point falls just before January 1st, 2015. So I would say that the release date was somewhere in late December 2014. Problem number 3 from 8th grade Unit 5, Lesson 8. A recipe for bread calls for 1 teaspoon of yeast for every 2 cups of flour. A. Name 2 quantities in this situation that are in a functional relationship. The amount of yeast and the amount of flour are in a functional relationship. B. Write an equation that represents the function. Let's start with a chart with yeast on one side and flour on the other. The information tells us for every 1 teaspoon of yeast, there's 2 cups of flour. Y represents yeast and F represents flour. Since 1 is half of 2, and y equals 1, and f equals 2, we can say that y equals half of f. That's if the amount of yeast is treated as a function of the amount of flour. If the amount of flour is treated as a function of the amount of yeast, then the equation is f equals 2y. C. Draw the graph of the function. Label at least 2 points with input-output pairs. The f-axis across the bottom, I'm counting in 2's for the cups of flour, 2, 4, 6, 8, and 10. Each green mark represents 2 cups of flour. You don't have to count by 2's, that's just how I set it up. The vertical axis is labeled T for teaspoons of yeast, and I counted by 1's. Each mark represents 1 tablespoon of yeast. 1 point on the line for this graph is at 4 and 2, meaning for every 4 cups of flour, there's 2 teaspoons of yeast. Another point on this line is located at 8 and 4, meaning for every 8 cups of flour, there's 4 teaspoons of yeast. Here's a different graph. This time, the horizontal axis is the t-axis, teaspoons of yeast, counting by 1's, and the vertical axis, I have the cups of flour. And again, I counted for the cups of flour in 2's. For this graph, I have a point located at 2 and 4, meaning for every 2 teaspoons of yeast, there's 4 cups of flour. And my second point is located at 4 and 8, meaning for every 4 teaspoons of yeast, there's 8 cups of flour. I drew this graph by hand, so it's not perfect, but I can start at the origin and draw a line right through the 2 points to make my line. Search hashtag 8th grade, Unit 6, Lesson 6, Math to find this lesson fast. 8th grade Illustrative Mathematics, Unit 6, Lesson 6, the slope of a fitted line. Take a moment to give this video a thumbs up. I appreciate it. Problem number 1. Which of these statements is true about the data in the scatter plot? A. As x increases, y tends to increase. As the value for x increases, we can see that the value for y decreases. If we plot the points and show the line of the graph, we can see that the slope of the line goes down, and this shows that as x increases, y tends to decrease. So this one wouldn't be true. B. As x increases, y tends to decrease. Yes, that is true. We just proved that. C. As x increases, y tends to stay unchanged. Well, we know that's not true. And then finally, D. X and y are unrelated. That's not true either, because you can see that the points on this graph go down as the value for x increases. Problem number 2. Here's a scatter plot that compares hits to at-bats for players on a baseball team. Describe the relationship between the number of at-bats and the number of hits using the data in the scatter plot. As the number of at-bats increase, the number of hits also increase. Problem number 3. The linear model for some butterfly data is given by this equation. Which of the following best describes the slope of the model? Description A. For every 1 millimeter, the wingspan increases, the length of the butterfly increases 0.238 millimeters. When the wingspan is 0, the length of the butterfly is 4.642 millimeters. But when the length of the wingspan increases 1 millimeter, the length of the butterfly becomes 4.880 millimeters, which is a difference of 0.238 millimeters. So description A describes the slope of the model perfectly. Problem number 4 from 8th grade Unit 6, Lesson 4. Non-stop, one-way flight times from O'Hare Airport in Chicago and prices of a one-way ticket are shown in the scatter plot. A. Circle any data that appear to be outliers. I'll circle this one obvious outlier. B. Use the graph to estimate the difference between any outliers and their predicted values. The predicted value of this outlier would lie on this line at approximately 187.50, and the outlier is approximately 437.50. That's a difference of $250. Problem number 5 from 8th grade Unit 4, Lesson 14. Solve. Y equals this expression and y equals this expression. Since y equals y, we can just write this expression equals this expression. Now let's solve for x. Add 3x to both sides. Subtract 1 from both sides. 1x equals 12, or x equals 12. Now that we know that x equals 12, we can substitute the x in this equation with the value 12. Now it reads y equals negative 2 times 12 plus 1. Which is equal to y equals negative 23. Now we know that x equals 12 and y equals negative 23. That's the solution. Search hashtag 876math to find this lesson fast. That's hashtag 8th grade, Unit 6, Lesson 7, Math. 8th grade Illustrative Mathematics, Unit 6, Lesson 7, Observing More Patterns in Scatter Plots. Right now, give this video a thumbs up. I appreciate it. Problem number 1. Literacy rate and population for the 12 countries with more than 100 million people are shown in the scatter plot. Circle any clusters in the data. Both of these groups of points are considered clusters in the data. Problem number 2. Here is a scatter plot. Select all the following that describe the association in the scatter plot. We can select A, linear association, because the points form a line. And that means that we won't select B, non-linear association. As the weeks increase, the weight also increases. That's forming a positive slope, so it does have a positive association, so we can select C, which means we won't select D, negative association. And since we selected A and C, linear association and positive association, we won't select E, no association. Problem number 3 from 8th grade Unit 6, Lesson 5. For the same data, two different models are graphed. Which model more closely matches the data? Explain your reasoning. Let's look at Model A. The points are evenly distributed and close to the graph's line. Let's compare that with Model B, where most of the points are above the graph's line. I'd say Model A more closely matches the data because the points are distributed closer to the graph's line. Problem number 4 from 8th grade Unit 6, Lesson 3. Here is a scatter plot of data for some of the tallest mountains on Earth. The heights in meters and year of first recorded ascent is shown. Mount Everest is the tallest mountain in this set of data. A. Estimate the height of Mount Everest. The horizontal axis represents the first ascent, and the vertical axis represents the height of the mountain in meters. This outlier at the top represents Mount Everest, and it looks like it's just above the 8,800 meter mark. So we could say it's about 8,850 meters or so. B. Estimate the year of the first recorded ascent of Mount Everest. Draw a vertical line straight down from the point, and it takes you to just after 1950. So we could say that the first recorded ascent was approximately 1953 or so. Problem number 5. From 8th grade Unit 5, Lesson 18. A cone has a volume V, radius R, and a height of 12 centimeters. A cone has the same height and 1/3 of the radius of the original cone. Write an expression for its volume. The formula for the volume of a cone is V equals 1/3 pi times r squared times its height. In this problem, there are two cones. There's the original cone, and there's a cone that has the same height and 1/3 of the radius of the original cone. We can use this formula to help us. We can insert the 1/3 of the radius, and we can substitute the h with the 12 centimeters for the height. The order of multiplication doesn't matter, so we can do 1/3 of 12. 1/3 of 12 is 4. Let's look at the 1 over 1 times pi. That's the same as 1 times pi, or pi. We can rewrite 1/3 r squared as 1/3 squared times r squared. Since the order doesn't matter, we can move r squared to the end. 1/3 squared, or 1/3 times 1/3, is 1/9. 1/9 times 4 is 4/9. Again, since the order of multiplication doesn't matter, we can move these around. 4/9 times pi times r squared. The volume of the cone described in A is 4/9 pi times r squared, or 4/9 pi r squared. B. A cone has the same height and 3 times the radius of the original cone. Write an expression for its volume. For this one, we can use the formula for finding the volume of a cone. Instead of substituting the 1/3 in front of the radius, we'll substitute a 3 in front of the radius. And it has the same height, so we'll keep the height at 12. 3r all squared becomes 3 squared, or 9 times r squared. Since the order of multiplication doesn't matter, we can move the r squared to the end. 1/3 of 9 is 3. 3 times 12 is 36. So the volume of this cone is 36 pi r squared. Search hashtag 8th grade, Unit 6, Lesson 8, Math. 8th grade Illustrative Mathematics. Unit 6, Lesson 8, Analyzing Bivariate Data. Right now, go ahead and like this video. I appreciate it. Problem number 1. Different stores across the country sell a book for different prices. The table shows the price of the book in dollars and the number of books sold at that price. A. Draw a scatter plot of this data. Label the axes. The horizontal axis is the price in dollars, and the vertical axis is the number of books sold. B. Are there any outliers? Explain your reasoning. Yes, there is an outlier. It's the point located far away from the line. C. If there is a relationship between the variables, explain what it is. When the price increases, sales decrease. D. Remove any outliers and draw a line that you think is a good fit for the data. Problem number 2 from 8th grade, Unit 6, Lesson 7. Here is a scatter plot. Select all the following that describe the association in the scatter plot. A. Linear association. These points that are scattered on this plot do not form a straight line, so this one's a no. B. Nonlinear association. Since these points that are scattered on this graph do not form a straight line, we can pick this one. C. Positive association. As the age increases, the weight also increases, so there is a positive association. Since it has a positive association, we know it can't be D, negative association. Since it has a linear association and a positive association, we know it won't be E, no association. Problem number 3 from 8th grade, Unit 6, Lesson 6. Using the data in the scatter plot, what can you tell about the slope of a good model? A. The slope is positive. The data in this scatter plot shows that the slope is going to be negative because it starts out high and goes low. A positive slope would start out low and go high. B. The slope is 0. The data in this scatter plot show that it has a negative slope, so we know that it can't have a 0 slope. C. The slope is negative. We've already determined that the slope of this line is negative. You can also tell by looking at the axes. As the horizontal values increase, the vertical values decrease. That means it has a negative slope. D. There is no association. We know that that's not true because the data in this scatter plot actually forms a slope. 8th grade Illustrative Mathematics, Unit 6, Lesson 9, Looking for Associations. Problem number 1. A scientist wants to know if the color of water affects how much animals drink. The average amount of water each animal drinks was recorded in milliliters for a week and then graphed. Is there evidence to suggest an association between water color and animal? No. The relative frequencies of the animals drinking each color of water are about the same, so there is no evidence of association. Problem number 2. A farmer brings his produce to the farmer's market and records whether people buy lettuce, apples, both, or something else. Make a table that shows the relative frequencies for each row. Use this table to decide if there's an association between buying lettuce and buying apples. First, let's figure out how many people bought lettuce. 14 people bought lettuce and bought apples, and 58 people bought lettuce and didn't buy apples. That's a total of 72 people who bought lettuce. Now let's find the number of people who did not buy lettuce. 8 people did not buy lettuce but bought apples, and 29 people did not buy lettuce and did not buy apples. That's a total of 37 people who did not buy lettuce. 14 out of 72 people bought apples and bought lettuce. That's 19% of the people. 58 out of 72 people did not buy apples but did buy lettuce. That's 81% of the people. 8 out of 37 people did not buy lettuce but they bought apples. That's 22% of the people. And 78% of the people did not buy apples or lettuce. The percentages in each column are close, so there's not enough evidence to suggest an association between buying apples and lettuce. Problem number 3. Researchers at a media company want to study news reading habits among different age groups. They tracked print and online subscription data and made a two-way table. A. Create a segmented bar graph using one bar for each row of the table. These segmented bar graphs represent the percentage of media for each age group. The yellow section represents internet media, and the red striped section represents print media. B. Is there an association between the age groups and the method they use to read articles? Explain your reasoning. Yes, there is an association because the segments of the bars are not very close to being the same size. Younger age groups use internet articles much more than print articles. Older age groups use much more print articles than internet articles. Problem number 4 from 8th grade Unit 6, Lesson 6. Using the data in the scatter plot, what is a reasonable slope of a model that fits this data? We can find a reasonable slope for this data by drawing a straight line evenly through the middle of the points on the scatter plot. This line almost goes through the intersection of 12 and 1980. So I'm going to put a little point right there on the line. And this line also almost goes through the intersection of 16 and 1990. So I can put a point right there too. Remember, to find the slope of a line, you use the rise over the run. And in this case, the rise goes from 1980 to 1990. So the rise is plus 10. And the run goes from 12 to 16, which is plus 4. So the rise is 10 and the run is 4. The slope is 10 over 4. Since 10 divided by 4 is 2.5, then we can say that the slope of this line is approximately 2.5. 8th grade Illustrative Mathematics, Unit 6, Lesson 10. using data displays to find associations. Problem number 1. An ecologist is studying a forest with a mixture of tree types. Since the average tree height in the area is 40 feet, he measures the height of the tree against that. He also records the type of tree. The results are shown in the table and segmented bar graph. Is there evidence of an association between tree height and tree type? Explain your reasoning. 45 out of the 75 deciduous trees are under 40 feet. That's equal to 60% of the trees. So 60% of the deciduous trees are under 40 feet. That means that the remaining 40% of the deciduous trees must be 40 feet or taller. 14 of the 24 evergreen trees are under 40 feet. That's about 58%. That means that the remaining 42% of the evergreen trees must be 40 feet or taller. In total, there are 59 trees that are under 40 feet, both deciduous and evergreen. That's 59 trees out of a total of 99 trees. That's almost 59%. That means that the remaining 41% of the trees would be 40 feet or taller. Look at the segmented bar graph at the bottom. Both the deciduous trees and the evergreen trees have a similar bar graph. That bar graph tells me that there's no association between tree height and type of tree. To answer the question, I can say no. 60% of the deciduous trees are under 40 feet and 40% are at least 40 feet tall. And 58% of the evergreen trees are under 40 feet and 42% are at least 40 feet tall. Since these numbers are so similar, there's no association between tree height and tree type. Problem number 2. Workers at an advertising agency are interested in people's TV viewing habits. They take a survey of people in 2 cities to try to find patterns in the types of shows they watch. The results are recorded in a table and shown in a segmented bar graph. Is there evidence of different viewing habits? If so, explain. In the table, I can see that Topeka watches much more news than Chicago does, and I see that Topeka watches a lot more drama than Chicago does. The table also shows that Chicago watches a lot more comedy compared to Topeka. The numbers in the reality TV column are just about the same, so we can say that Topeka and Chicago watch about the same amount of reality TV. In looking at the bar graph, you can see the similarities and the differences. And since there's differences, we can answer this question by saying yes, Topekans watch news and dramas a lot more than Chicagoans. Chicagoans watch comedies a lot more than Topekans do. Topekans and Chicagoans watch about the same amount of reality TV. Problem number 3. A scientist is interested in whether certain types of butterflies like certain types of local flowers. The scientist captures butterflies in 2 zones with different flower types and records the number caught. Do these data show an association between butterfly type and zone? Explain your reasoning. When he captured eastern tiger swallowtail butterflies, he captured 16 of them in zone 1 and 34 of them in zone 2. When he captured monarch butterflies, he captured 24 in zone 1 and 46 of them in zone 2. 16 plus 34 equals 50. 16 out of 50 is 32%. So 32% of the eastern tiger swallowtail were captured in zone 1. That means that the remaining 68% were captured in zone 2. 24 out of 70 equals about 33%. So 33% of the monarch were captured in zone 1. That means that the remaining 67% of the monarch were captured in zone 2. The percentages in zone 1 are very similar, 32% and about 33%. They're also very close in zone 2, 68% and about 67%. So I would answer the question by saying no, there is not an association. There is not a large enough difference in the type of butterfly found in zone 1 and zone 2. If you haven't subscribed yet, be sure to subscribe to my channel and watch the next lessons. Thanks for watching. I'll see you next time.